Apparently, some of you are struggling with the hypothesis testing procedure, knowing what the steps are and what you're supposed to do when you are asked to conduct a hypothesis test. So I want to review very quickly what those steps are and then look at a couple of examples. So the first step, after you've read the scenario, whether you're doing a one mean z test, a one mean t test, a two mean test, chi-square goodness of fit, or analysis of variance, this is the process. Step one, after you've read the scenario, you want to state the null hypothesis and the alternative hypothesis. There are always two hypotheses. One of them is stated in the scenario itself. Usually towards the end of the scenario, oftentimes in a question format, you want to look for words like claim, believe, think, conclude, want to determine, and then that should help you to identify your hypothesis. You also have to identify whether it's the null hypothesis or the alternative hypothesis. That is totally going to depend upon the phrasing and the words within the statement. Step two, I like to say to identify the players. The players are the needed information that you may need to put into Minitab or into whatever statistical analysis tool you're using. For this course, we are using Minitab. So do you need the population mean, the population standard deviation, the sample mean, the sample size, the level of significance, the expected values? What do you need? So you identify your needed information. Third is using Minitab, you calculate the test statistic and its corresponding p-value. Okay, Minitab does all the work for you. You just have to use the appropriate commands. Now, the commands do vary depending upon which test you're using. Step four is you make a decision to reject the null hypothesis or fail to reject the null hypothesis by comparing the p-value you get from Minitab and the given level of significance. Now, unless you forgot, in case you have forgotten the rules, these guidelines are the same regardless of what type of hypothesis test you're doing. It says if the p-value is less than or equal to the level of significance, then you reject the null, which means the null hypothesis is false or wrong. If the p-value is greater than the level of significance, then you fail to reject the null, which means the null hypothesis is true or correct based on the data or the information that you have. Once you've made a decision, you write a conclusion using a complete sentence and including the level of significance. The conclusion is written in terms of the true hypothesis. Okay, so I'm going to work through a couple of examples for you, and I'm using the examples or the problems from the discussion 5 that apparently a number of you struggled to complete. So because apparently you didn't know what to do, so I want to walk through those. So the first scenario reads, it is common knowledge that a human's normal body temperature is 98.6 degrees Fahrenheit. Assume that the standard population standard deviation is known to be 0.62 degrees Fahrenheit. In a recent study of 106 human body temperatures, researchers found a mean of 98.2 degrees Fahrenheit. Conduct a hypothesis test that uses a 0.05 significance level to test the claim that the mean body temperature of the population is less than 98.6 degrees Fahrenheit. Okay, first of all, you have to identify your claim or your hypothesis. Again, as I stated earlier, typically that's towards the end of the problem. I tried to help you out on this particular assignment because I put it in bold print. Also, if you look for that keyword, it says test the claim. So my hypothesis is the mean body temperature of the population is less than 98.6 degrees Fahrenheit. Okay, so we got to think about this just a little bit. If I look at that phrase, is less than, I hope you think of the mathematical symbol that represents less than. And less than does not contain equal. Therefore, this statement that I have highlighted in yellow is your alternative hypothesis. So my first step, and I'm going to do it above here, is to state your null hypothesis and your alternative hypothesis. The one that I have highlighted is my alternative, and I'm basically going to take the words and translate them to symbols. The mean body temperature of the population is less than 98.6 degrees Fahrenheit. I know that the null and the alternative are exact opposites, and that the null must always and forever contain equal in some form. So I would have the mean is greater than or equal to 98.6 degrees Fahrenheit. And there are my hypotheses. So that is step 1. I have stated my hypotheses. Step 2 is to determine which test you're going to do. Are you doing one mean z, one mean t? Are you doing chi-square? Are you doing ANOVA? Which one are you doing? Well, again, if I think back to reading this problem, I notice in the second sentence it tells me that the population standard deviation is 0.62 degrees Fahrenheit. So based on that fact, I know that I'm going to do a one mean. I'm using one mean because I only have information about one thing, which is the body temperature. One mean z test because I know the population standard deviation. Then I'm ready because I know that I'm doing a one mean z test. That tells me what information I need. To do a one mean z test, I need the population mean, I need the population or known standard deviation. Minitab uses the word known. I need the sample mean. I need the sample size. And I need the level of significance. And all of that information is given to me in my scenario. The population mean, Minitab, I believe, refers to that as the hypothesized mean. And they refer to it that way because it's the value that's in the hypothesis. So for us, that is 98.6 degrees Fahrenheit. I have the population standard deviation highlighted in green, in my paragraph above. So it's 0.62 degrees Fahrenheit. If I go back and read a little bit more, kind of scan it, in the third sentence it says, in a study of 106 human body temperatures, so that tells me that my sample size was 106. Researchers found a mean, and again, for some people that's not as obvious because it doesn't say exactly, it doesn't say sample mean, but it's talking about those 106 people. So my sample mean is 98.2 degrees Fahrenheit, and it says use a 0.05 level of significance. So I have all of the information that I need. So once I've gathered all that information, I'm going to go out to Minitab. We go to Stat, Basic Statistics, 1 Sample Z. I have summarized data. My sample size was 106. My sample mean was 98.2. The known standard deviation was 0.62. You do need to perform a hypothesis test. My hypothesized mean, or my population mean, was 98.6. My level of significance was 0.05, or 5%. Therefore, my confidence level is 95%. And then I have to match the alternative hypothesis. The alternative hypothesis was less than. And I click OK. OK. And then I get my results. I'm looking for the test. My test statistic is negative 6.64 with a p-value of 0. So I have to write those things down. Okay, so I'll come back to my paper, and on my paper, step 3 was to calculate the z and the p. So my z test statistic is negative 6.64. The corresponding p-value is 0. I then need to make a decision. To make a decision, I compare that p-value that I just got from Minitab of 0 to alpha, which is my level of significance. Now, I usually tell students to do this digit for digit, okay, to try to avoid a mistake. So if I compare the first digit after the decimal, 0 to 0, there appears to be no difference. Then I have 0 compared to 5. 0 is less than 5, so P is less than alpha. The guidelines say when P is less than alpha, we are going to reject the null. Now, what that means, if I go back up here to the beginning, If I reject the null, that means the null is false or that it's wrong. And the alternative then by default is true or correct. So when I write my conclusion, I've got to write it so that it indicates that it's less than 98.6 degrees Fahrenheit. So then I'm going to write my conclusion. I'm going to write that final sentence that kind of wraps it all up and gives me the answer. And we say, at the 0.05 level of significance. You always include the level of significance. The mean body temperature of humans is less than 98.6 degrees Fahrenheit. Okay, because the true statement, the one we found to be true, was that it was less than. So you have to phrase it in that manner. Guys, you don't have a complete hypothesis test unless you go through all of those steps. All right, let's look at the second one. It reads, according to data from the National Environmental Education Foundation, on average, a United States resident uses 91 gallons of water per day in and around his home. Assume the population standard deviation is known to be 27.3 gallons per day. A researcher randomly selects 16 U.S. residents and found that they used on average 119 gallons per day in and around their home. Conduct a hypothesis test that uses a 0.05 level of significance to test the claim that the mean amount of water used per day in and around a home is not 91 gallons. Now here again, one of the first things you have to do is to identify your hypothesis. Again, looking for words like claim, believe, think. So again, I tried to help you out by highlighting it in bold, and again, it's typically near the end of the question. And again, looking at my phrasing, it says is not, which makes me think that it's not equal. So it makes me think of this symbol. So again, this statement is my alternative hypothesis because it doesn't contain equal. So my first step, as is the case in any hypothesis test, is to state the hypotheses. And again, the one that I'm given is the alternative. So I'm going to translate the words to symbols. The mean is not 91 gallons. Knowing that the null is the exact opposite and must contain equal, the null would be the mean equals 91. I then need to determine which test I'm going to conduct. Again, if I go back and kind of scan the problem, in the second sentence again, it gives me my population standard deviation. So once again, here we want to do a 1 mean z-test because I know the population standard deviation. If I'm doing a 1 mean z-test, then I need the population mean, the population standard deviation, the sample mean, the sample size, and the level of significance. Now, those 5 things don't change in terms of a Z test. So you may want to make yourself a note card or a note that that's the things you need. So the population or the hypothesized mean, which comes from the hypothesis, is 91. The population standard deviation I had highlighted in green. That's 27.3. Again, if I go back and read a little bit, it says researcher randomly selected 16 U.S. residents, so that's my sample size, and on average, they used 119 gallons per day in and out. So my sample mean is 119. My sample size was 16, and it says using a 0.05 level of significance. Okay, so once I've identified all of that information, I'm then ready to go out and put it into Minitab. So here we go out to Minitab again. Stat, basic statistics, one sample Z. Again, we have summarized data, meaning they're giving us the population mean, the population standard deviation, the sample mean, and all that. Okay, so I'm going to change these numbers. My sample size this time was 16. My sample mean was 119. The known standard deviation was 27.3. My hypothesized mean was 91. Again, we're doing a 5% significance level, so it's a 95% confidence level. And this time, we're saying it's not equal. So I click OK. I click OK. And I look for my test. And we get a Z score of 4.10. Okay, so recording it, my Z test statistic is 4.10, and my p-value is 0. So again, at that point, we want to make a decision by comparing the p-value that we just got from Minitab to the level of significance that was given to us in the problem, which is 0.05. Again, if you'll compare it digit for digit, first number after the decimal point, no difference. Second number, 0 compared to 5. 0 is less than 5, so P is less than or equal to alpha. When P is less than or equal to alpha, we always reject the null. Now, again, thinking about what that means, if I reject the null, that means the null is false or wrong, and the alternative is true or correct. And so when I write my final conclusion, I have to write it in terms of that alternative hypothesis. Okay, so we would write our conclusion, again, making sure to include that level of significance, at the 0.05 level of significance, the mean amount of water a U.S. resident uses day in, uses per day, sorry, per day in and around a home is not 91 gallons. Guys, you have to write the full sentence. It's not texting style. It's not shortcut. It's not shorthand. You have to write that full, complete sentence. All right, let's look at the third one. A certain prescription allergy medicine is supposed to contain an average of 245 parts per million of a certain chemical. If the concentration is higher than 245, the drug will likely cause unpleasant side effects. And if the concentration is below 245, the drug may be ineffective, meaning it doesn't work. The manufacturer wants to check whether the mean concentration in a large shipment is the required 245 parts per million or not. To this end, a random sample of 64 portions from the large shipment is tested, and it is found that the sample mean concentration is 250 parts per million with a sample standard deviation of 12 parts per million. Conduct a hypothesis test that uses a 0.01 significance level to test the claim that the mean concentration is 245 parts per million. Now, here again, we need to initially identify the hypothesis. We again look for those words: claim, believe, think, conclude. I have it highlighted in bold print. So my hypothesis is the mean concentration is 245 parts per million. So this says is. Is a synonym for the mathematical word equal. And since that's equal, that statement is my null hypothesis. So we begin, as you do any hypothesis test, by stating your null and your alternative hypothesis. Again, we're translating words to symbols. The mean concentration is 245. I know that the alternative is the exact opposite. The exact opposite of equal is not equal to 245. I then need to decide which test I should conduct. That is determined by whether or not I have the population standard deviation or the sample standard deviation. So if I scan back through this, near the end of the paragraph, I have the sample standard deviation of 12 parts per million. Nowhere in this paragraph does it state or refer to the population standard deviation. So because of that fact, for this particular problem, we're going to do a one mean t-test. And we do that because I do not know the population standard deviation. Now, because we've decided that we're going to do a one mean t-test, the information that we need changes slightly. You still need the population mean, or what Minitab calls the hypothesized mean. But instead of the population standard deviation, you need the sample standard deviation. You still need the sample mean. You still need the sample size. And and you still need the level of significance. So really the only piece that changes is instead of the population standard deviation, you have the sample standard deviation. But everything else is given in the problem. So my hypothesized mean from the hypothesis is 245. I highlighted the sample standard deviation in green a minute ago. It's 12. If I go back up and I read through my paragraph again or scan it, it says a random sample of 64 portions yielded a sample mean concentration of 250 parts per million. So I tested 64, that's my sample size, and got a mean of 250, and it says to use a 0.01 level of significance. So I've gathered all my information, going out to Minitab. This time we go stat, basic statistics, one sample t, because we are doing a t-test. Again, we are given the summarized data. We have the values already determined for us. Our sample size was 64. The sample mean was 250. The standard deviation was 12. We are performing a hypothesis test. The hypothesized mean is 245. We're using a 0.01 significance level, which means our confidence level is 99, and we need to choose the appropriate alternative hypothesis, and we are doing not equal in this problem. So I say okay, and then again I'm looking for the test results. I get my t-test statistic, which is 3.33, and my p-value is 0.001. So again, I come back to my paper to record those answers. My t-test statistic is 3.33. The corresponding p-value is 0.001. Then I need to compare that p-value that I just got from Minitab of 0.001 to the level of significance that I was given in the problem, which was 0.01. Again, if I compare that digit for digit, the first digit after the decimal, 0 compared to 0, no difference. 0 compared to 1, 0 is less than 1, so the p-value is less than or equal to the level of significance. Whenever p is less than or equal to the level of significance, we reject the null, which in this context means that my null hypothesis is false or wrong, and the alternative is true or correct. So again, when I write my conclusion, I have to write it in terms of the alternative. So I would write in my conclusion, at the 0.01 level of significance, the mean concentration is not 245 parts per million. Okay, one more. I know the video is getting long, but one more. The stock price for a particular company grows at an average rate of $5 per week. A potential investor believes the stock will not grow that quickly. A sample of the average change in the stock price for 10 weeks is collected, and the mean is found to be $2.60 with a standard deviation of $1.84. Conduct a hypothesis test that uses a 0.05 level of significance to test the claim that the average growth rate is below $5 per week. Again, I have it bolded, but you have the word claim in there. So my claim or my hypothesis is the average growth rate is below $5. So thinking about that phrase is below makes me think of less than, which doesn't contain equal. So this statement is the alternative. So I have to write my alternative hypothesis and my null hypothesis. The one I'm given is the alternative. So we're going from words to numbers. The average growth rate is below $5 per week. I know that the null is the exact opposite, and it must always and forever include equal in some form. So the mean is greater than or equal to $5. We then have to decide what type test we're going to conduct. So if I scan back through my problem, it gives me a standard deviation. It doesn't specify whether it is the population or the sample. But if you look at the context, the sentence that it's in, it says a sample. Okay, so that implies that this refers to the sample. So because I have the sample standard deviation, that tells me that I'm going to do the one mean t-test, because I do not know the population standard deviation. So knowing now that I'm going to do a one mean t-test, I need to identify all of my information. I need the population mean, the sample standard deviation, sample mean, sample size, and level of significance. The population or hypothesized mean is 5. The sample standard deviation, which I highlighted in green, is $1.84. If I go back up and look at the paragraph again, it says a sample, let's see, for 10 weeks, and we get a mean of $2.60. Okay, so my sample mean is $2.60. My sample size is 10. And let's see, I didn't catch it. Use a 0.05. So alpha is 0.05, the level of significance. Okay, so I've collected all of my information. I'm going out to Minitab. stat, basic statistics. Whoops, I hit the wrong one, sorry. Stat, basic statistics, 1 sample T, again using summarized data. My sample size this time was 10. My sample mean was $2.60. My standard deviation was $1.84. My hypothesized mean was $5. We're doing 5% or 0.05, so my confidence level is 95. And my alternative hypothesis is that it is less than or was below $5. So I'll click OK. OK. Oops, I got a typo. Fix that. Look for the test, and we get a test statistic of negative 4.12 with a p-value of 0.001. So I'm going to record that, write it down. My t is negative 4.12. The p-value is 0.001. I've got to make a decision by comparing the p-value, which is 0.001, to the level of significance, which is 0.05. Digit for digit. First digit after the decimal, 0 compared to 0. Second one, 0 compared to 5. 0 is less than 5. So P is less than or equal to alpha. If P is less than or equal to alpha, we reject the null, which yet again means that the null is false or wrong, and the alternative is true or correct. Again, you always write it in terms of the true hypothesis. So it is less than $5. So we would write, make sure you include your level of significance, at the 0.05 level of significance, the mean amount, see, I don't remember what it said, the mean amount, or mean growth rate, let's see, sorry, the mean growth rate is below or is less than $5. Because I think some of you are overthinking it. Some of you don't understand the process. And some of you are using other techniques that I haven't shown you how to do. And in some cases, you're not applying them correctly. Okay? So hopefully this will help you to kind of get on track with the hypothesis testing, because it is not going to go away. You're going to continue to see it throughout Module 4.